lesson day 4, where we're going to talk about stem plots. Your learning target today is I can make a stem plot and describe it with socks. So we're going to start with a review like we always do. The following pie chart shows the responses to a survey given to 250 adults about how they get to work each day. And I know those numbers are a little hard to see on your notes, but it says train 10%, car 40%, bicycle 30%, and bus 20%. So is this data categorical or quantitative? So remember, you're talking about the question being asked and what the answers were received. So anytime you see a pie chart or a bar graph, it is automatically categorical. We ask people, how do you get to work? Categorical. And they give us word responses. They said train, bike, car, or bus. Now, part B says, how many adults said they get to work by car? Well, if we look at car, it's this piece here that says 40%. All right, but they're not asking for the percentage, they're asking how many. So what we have to do is we have to take 40% of the amount of adults surveyed, which they told us was 250. So that looks like 0.4, because that's 40 as a decimal, times the 250 adults that we have. And 0.4 times 250 will give you 100 adults. Next one, question C says, what percent of adults said they get to work by bus or by train? Well, bus is right here at 20%, and train is right here at 10%. And since they're asking for the percentage, and we already have percents, we just go ahead and add these two percentages together. 20% plus 10%, well, that gives us a total of 30%. Now question D says how many degrees, that should be an S on the end of that, are in the bicycle section. So if we look at the bicycle, it's 30%. But they're asking how many degrees. So remember, we take the percentage and we multiply it by the total number of degrees in a circle, which is 360. So our percent of 30% written as a decimal is 0.3, and we're going to multiply that by 360. And when you do that, you are going to end up with 108 degrees. Now part E asks us to make a well-labeled bar graph of the data. Okay, so when you make well-labeled bar graphs, remember we start with the title. So we're talking about how adults get to work, or their work commute is what I'm going to call this. Work commute. Okay, and all of our data is then represented with percentages. So that would be a relative frequency. Okay. That's what I'm going to title this side, relative frequency. I'm being kind of lazy there. You probably could be more specific and say percent of adults, right? And then we're going to label the side. Our biggest percentage in there was 40%. So we just got to make sure we get to 40%. I'm going to skip every other line and go up by tens. So starting at 0, skip a line 10, skip a line 20. So that way each one of these lines is really representing 5%. This way we get all the way up to 50% at the top. Okay, then we have to go ahead and label each one of these categories. So we got train, car, bicycle, bus, right? So train we'll keep as purple, orange. Again, I'm going to use 2 spaces here, so train. And then the next one, we can do car, which is in red. Okay, and bus and bicycle, so the bus being green and bicycle being blue. Bus will be green and bike will be blue. Okay. And we can call these modes of transportation or just method. I'm going to go with method because it's shorter. So the method of transportation is train, car, bus, or bike. Now all we have to do, everything is perfectly labeled, so we go ahead and draw in our bars. We see that train is only 10%, so we go up to the 10%, come over, and then shade that in. Car is 40%, our biggest one, so we find where car is at, we go all the way up to 40, back down, then shade. Bus is our next one, it was 20%, so we go up to 20 over and down, shaded in. And lastly, the bicycle, which was 30%. So up to 30 over and down. Okay. So that is our bar graph for that one. Next question says, the following dot plot shows how many siblings students have in a class, or in a class have. So describe the dot plot using SOCS, right? So this would be one of those ones where we might say, describe the distribution of the data. Well, in order to describe the distribution of the data, we use our acronym, SOCS. First one being, the first S is for shape. So if we draw a curve along here, the shape of this data, to me, looks like it's skewed to one side, right? Looks like it's skewed and our tail is on the right, so we call it skewed right. Okay, then we talk about the outliers, right? I have an outlier right here for O, so I would say one outlier at 9 siblings. We'll label it this time. Good habit to get into. So 1 at 9 siblings. Then we talk about center. So remember, for center, we go ahead and figure out what the middle number is, or the median. Is what we're looking for. And we're going to have some math to do. So if we count up all these dots, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay, so you take the count. That's step number 1. Divide it by 2. Which gives us 8. And if it's a whole number, remember we take the next number as well. So 8 and 9. So now we have to count up and see where our dots 8 and 9 are. So we got 1, 2, 3, 4, 5, 6, 7, 8, 9. So 8 and 9 are right here. They're both at 3. So our median is 3 siblings. Okay, and the last one, the one that you shouldn't ever overthink, it's the spread. You simply need to tell me the smallest number in our data. Well, the smallest number, make sure you realize it's not 0, it's where the dots are. So it's at 1, that's our smallest, and our largest is at 9. Okay, so you say from 1 to 9 siblings. All right, that's how you describe data using SOCS. Okay, so flip the page, and now we're gonna move on to stem plots. So for stem plots, we have a box just like the dot plots. So they are a way to show quantitative data. Go ahead and pause this video so that way you have the time to copy all this stuff down. Once you have that stuff copied down, we're gonna go ahead and scroll down to look at the following data. It's the results of a survey given about how many shoes the individual owns. Make a well-labeled stem plot of the data. Okay, so stem plots, they're just like box plots, right? The only thing is that we split the numbers in half, into 2 parts, I should say. We put them in order, organized by stem, and we go from there. So what does that mean for us? This 1 on the left side means we're going to look for all the numbers that start with a 1, meaning we have 13, 13, another 13, okay? But there's nothing, and a 15. All right, then there's also a 19 up top. So those all start with a 1. And we're going to put those in order from least to greatest. So you put 3 3s in a row because that's a 13, then another 13, then another 13, 15, 19. Now notice how I am evenly spacing these numbers out. That's going to be important for us, especially when we get to the step of doing shape and describing it using SOCS. Okay? Now we look for all the ones that start with 2. So we got 26, 26, 23, 24, 22, 23. Okay, so when we put those in order from least to greatest, it's going to go 22, 23, 23, 24, 26, 26. Notice how I made those numbers line up with the ones in red. We can go ahead and cross those off. And we move on to the 30s. So for the 30s, we have 31, 34, 30, and 38. So when you have 30, you put a 0 on this side. So that represents 30. And then we got 31, 34, 38. Jump to the next set of numbers after we cross those out. The next set of numbers is going to be in the 40s now. So anything that starts with a 4, I have 49, and that's it. So we go ahead and write 49 down here with a 9. And lastly, into our 50s. So it's everything that's left, basically. 2 50s, a 51, and a 57. So it's going to be 0, 0, 1, 7. Okay? Now, the most important things of this, and I kind of skipped this step, so I apologize for that. But the most important things is that you need to make a well-labeled one, it says, right? So, this tells us number of shoes as our title. Okay, and it's already labeled stem and leaf for us, so that's good. Now this piece over here, the key. The key is super important. If you don't have a key, you're going to lose a lot of points because we don't know how to read a stem plot without a key. Okay, so to create the key, you just simply pick one of your numbers. I'm going to pick 23, and you'd write the 2, and then draw your line down the middle, and then the 3, and you write equals 23 shoes. Because that's what it's telling us. Okay? Just kind of weird to own an odd number of shoes, unless it was pairs of shoes. All right, then the last piece of this is describe the distribution of the data using SOCS. Right? Describe the distribution of the data using SOCS. So the first piece being your shape. The reason why we have to have everything nice and spaced out for us is so that when we do shape and we draw our curve in here, right, we can see what this looks like. I wouldn't say this is skewed in any direction. I would go ahead and just say that this is symmetrical. Or symmetric. Okay? Then the next one, we have outliers. We're looking for any outliers. I don't see any that are out there by themselves. Then we talk about center, right? So when we look at center, we need to find the median. So in order to find the middle number, we go through the process of first counting up how many numbers that we have. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. We have 20 numbers. So to find the median, we take 20, divide it by 2, that gives us 10, which is a whole number, so we take 10 and 11. All right, so let's count to 10 and 11. We got 5 numbers up top, 6, 7, 8, 9, 10, and 11 are both right here. So our median is 26. Make sure you don't just write 6. It's 26 shoes. And lastly, the spread. Fairly simple. Just look at the lowest number, which is going to be found here at 13. So we say 13 to the biggest number, which is the bottom and the last number here, so 57. So 13 to 57 shoes. Okay, so that is a stem plot from start to finish. All right, let's go ahead and flip the page. And that's our last page for the notes today. So the following data are the scores from the most recent essay in English 9. Make a well-labeled stem plot of the data and describe it with SOCS. So some of you might prefer to put this entire list into order right away. That's up to you. But I feel like I can put it into order as we go through it. We just need to find the lowest first digit, right? So when you look at all these numbers, which one has the smallest first digit? And I see 23, okay? And there's nothing smaller than 23. So my first stem is going to be a 2. Okay, and then we look for the biggest number in our list, which is 105, which means my biggest stem is going to be 10. Okay, so here's what it looks like. We go 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, and once you have that, then you go ahead and draw your line down the middle. And then we should title this thing, right? It says essay scores. So these are the essay scores, and now we go through our list and we find all the numbers that are in the 20s. So when we do that, there's only 23. Then we go to all the numbers in the 30s. There aren't any numbers in the 30s, so you can leave that part blank. Look for the 40s. There's a 43 up over here. Then we have 58 and 59. 58's here, 59's here. We have 61 and 67. Then we have 71, another 71, and a 72. We have an 80 and two 82s, so 82, 82. Then we have 93 and 94. And lastly, 105. All right. So then it tells us, well, if we got to finish our labeling, we got to make a key now. I'm going to assume that this is in percent. It doesn't really tell us, but if we have, I'm going to use 43 on this one, 4, then the line 3, we're going to call that 43%. So everything is labeled. We have a key. Our stem plot is done. The last thing it asks us to do is to go ahead and describe the data using SOCS. So we start with shape. Shape on this one. Okay, I would say that this is a tail down here. Right? And that tail down there means it's going to be skewed left. Right? Because if it's skewed towards the smaller numbers, that's left. If it was skewed towards the bigger numbers, that would be right. So we got skewed left. Then outliers. There's the lowest number here at 23. I would say the outlier would be 1 at 23%. That's what we're going to say there. 1 at 23%. To find the center, all right, we need to find the median. So when we go to find the median, we need to know how many numbers we have. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So you take the 15 total test scores or essay scores divided by 2. We get 7.5, which means we round up to the 8th number. And when you count to the 8th number, you get a median score of 71%. And lastly, the spread here, we just simply label the spread being 23% to 105%. Smallest number to biggest number. So that example shows two things to consider when making a stem plot. Make sure you pause your video to jot these down. You can represent numbers in the hundreds with stems with 10 and above. So if it's 115, we could do 1, 1 on the left side and then 5 on the right. Then don't skip stems even if there are no numbers in there, just like the dot plot, right? So this stem, we didn't skip the 30s just because there's no numbers in there. You have to include it. Okay. Now on to the last one. When learning estimation, a 4th grade class was asked to estimate the length of a piece of string in centimeters. The following stem plot shows the data. The actual length of the string was 4.7 centimeters. So here we have a labeled stem plot. Guesses of string length. It gives us the key on the side, that 3, and then the line 8 represents 3.8. So the question is, how many students were within 1 centimeter of the correct length? Okay, 1 centimeter. What does that mean for us? If the actual length was 4.7 centimeters. If we went 1 centimeter shorter, right, we'd be at 3.7. And if we went 1 centimeter longer, we'd be at 5.7. So we're looking for all the numbers between 3.7 and 5.7. So we have 1 here, and then we go 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So we'd say 17 students were within 1 centimeter of the correct length. Then part B says, what percent of students guessed that the string, is what that should say, was more than 5.5 centimeters long? So now, more than 5.5 centimeters long. We are looking at 1, 2, 3, 4 students. Okay, so if we go ahead and write down the number that we want, and remember to find the percentage, we divide it by the total number of guesses. So we had 21 guesses. We do 4 divided by 21, and we round that to the nearest whole percent this time, and let's do 19%. All right, that is it for your video notes. Go ahead and use the rest of your time to finish up your assignment, or get started and finish up your assignment. Make sure you show the sub that you have finished all of your notes.